Hello everyone, I am Likhita. I am currently pursuing my fourth year in Bachelor of Engineering CSE department in Sri Venkateswara College of Engineering. In this video, I am going to share a seminar titled Steganography. Coming to the contents, in this video, we will be discussing introduction, historical examples, literature survey, steps of steganography, types of steganography, image steganography, text steganography, audio steganography, results and discussion, conclusion, and references. Coming to the introduction, we can define steganography as the art of hiding messages in such a way that no one but the sender and the intended recipient knows about the very existence of the message. In simple words, steganography is the practice of representing information within another message or physical object in such a manner that the presence of the information is not evident to the human inspection. Steganography can be achieved by concealing the existence of information within seemingly harmless carriers or cover. Steganography comes from the Greek word where stegano means covered or secret and graphy means writing. So, steganography basically means secret or covered writing. Next, let's see a few historical examples of steganography. The first one is invisible ink, where the ink is made visible using some chemicals. The second one is the micro dot. Here, the dots are printed on the paper and are only visible by using microscope. And the third example is the person's head. In the past, Roman general would shave soldier's head and then the message is written or tattooed on the head. And then hair are again allowed to be grown and finally at the receiver's side, the head is again shaved to view the message. Next is the literature survey. So here are some literature surveys on steganography, which is the art and science of secret writing. During my literature survey, I researched on various classifications and techniques of steganography, recent developments in the techniques of steganography, and developments in the digital steganography. So, the first paper here is the steganography and the classification of image steganography techniques. And the next paper is a study on steganographic techniques. Then we have a comprehensive study of digital image steganographic techniques. And the last one is advances in digital image steganography. Now we have the general steps in steganography. So basically, there are two steps in steganography. One is the encoding of the message, and the other is the decoding of the message. Now, in the encoding of a message, the first step is preparing a cover data in which the data can be hidden. And in the second step, we have to encode the embedded data with the cover data. And finally, we obtain the steganographic data, which is ready to be transmitted. At the decoding side or at the recipient side, we have the steganographic data. So, the first step is to decode this steganographic data into plain data or information. And finally, the embedded data can be obtained at the recipient's side. Next, we have the types of steganography. There are majorly three types of steganography, namely image steganography, textual steganography, audio steganography. Coming to image steganography. Here, the important message is hidden using an image. So large images offers more data to be hidden, and thus it increases the size of the image. So compression of images is solution for larger images. There are two types of compression, the lossy compression and lossless compression. Lossy compression occurs commonly in JPEG format, and it has high compression of rate but no integrity of originals. But lossless compression has low compression rate but integrity of original data, and it commonly occurs in GIF format. The three common approaches in image steganography are least significant bit insertion, masking and filtering, algorithms and transformations. Coming to algorithms, the most common algorithm is static parsing steganography. Here, the sender and the receiver agree on a cover image. So, the protocol does not modify the cover image, rather determines the bits of the secret message that matches the one in the cover image and stores their different location in a vector, and then it is sent to the recipient. Another approach of image steganography is least significant bit insertion. Here, it replaces the least significant bits with the message to be encoded, and this is the most popular technique when dealing with images. LSB is best to use a grayscale palette or one with gradual changes in shades. Then otherwise, it is best to use images with noisy areas. Noisy areas here refers to areas with ample color variation and without large areas of solid color. So, as we can see in the figure, the least significant bits are replaced with the secret code which is present on the right side, and there is a slight variation in the color of the image. The next approach we have is masking and filtering. Masking is a process of hiding secret data over the original data by changing the luminance of particular areas. Masking embeds the message within the significant bits of the cover image. This method is not susceptible to lossy techniques because image manipulation does not affect the secret message. Now, coming to the uses of masking and filtering, the first one is the digital watermarking. Here, it provides identification pertaining to the owner, that is, license or copyright information, just as shown in the figure. And the second one is the fingerprinting, which provides identification of the user that can be used to identify and track illegal use of content. So the other person cannot access the information without the fingerprint of the owner. So the next technique in steganography is text steganography. This method involves hiding of an important message within another uninterested message. For example, consider the below message which says, since everyone can read, encoding text in neutral sentences is doubtfully effective. Now, when we take the first letters of the sentence, we get a secret message which says secret inside. This is one of the most common examples we have in text steganography. Now we have the techniques in text steganography. First we have is line shift encoding. What happens here is that the text lines are vertically shifted to encode the document. In simple words, the text lines are shifted up and down. Next is word shift encoding. Code words are coded into a document by shifting the horizontal location of the words within the text lines. In simple words, the text lines are shifted right or left. And the last technique is the feature coding. where certain text features are altered or not altered depending on the code word. Next, coming to the third technique in steganography, that is audio steganography. Here, we use audio to send the secret messages. There are three methods of audio data hiding. They are low bit encoding, phase coding, echo data hiding. Now, in low bit encoding, what happens is that the data is being hidden in least significant bits of audio samples. The weightage of LSBs in comparison with the combined weightage of whole sample is very small. Using more LSBs per sample increases the capacity and decreases the transparency. So there's always a trade-off between both these parameters, that is the capacity and the transparency. Here we can see a low bit encoder. First, the audio signal is converted to digital signal and then LSB is embedded and then finally this signal is again converted to the audio signal. At the low bit decoder side, first the audio signal is converted to digital signal and then LSB extraction is performed and thus the secret message has been obtained. Now, the next method in audio steganography is phase coding. Human auditory system or HAS can't recognize the phase change in audio signal as easy as it can recognize noise in the signal. The phase coding method works by substituting the phase of an initial audio segment with a reference phase that represents the data, achieving an inaudible encoding in terms of signal to noise ratio. So what happens here is that the original sound sequence is broken into a series of n short segments and then DFT is applied to each segment to break and create a matrix of phase and magnitude. The phase difference between each adjacent segment is then calculated. For segment SO, the first segment, an artificial absolute phase PO is created, and for all other segments, new phase frames are created. The new phase and the original magnitude are combined to get a new segment SN, and finally, the new segments are concatenated to create the encoded output. The last method in audio steganography is echo data hiding. The echo data hiding embeds the data into a host signal by introducing an echo. The data are hidden by varying three parameters of echo: the initial amplitude, decay rate, and offset or delay. The detection of the embedded signal then just involves the detection of spacing between the echoes. An example of echo data hiding is as shown in the figure. As we can see, the original audio has been modified by varying echo amplitude, offset, and decay rate. Now, coming to the results and discussion. The first application of steganography is confidential communication and secret data storing. The secrecy of the embedded data is essential in this area. The simplest application is our private journal writing. Attaching a stego file to an email message is another example in this application area. The second application we have is protection of data alteration. Here we take advantage of the fragility of the embedded data in this application area. One example is the information alteration protective system such as a digital certificate document system. If steganography is implemented, People can send their digital certificate data to any place in the world through internet. No one can forge, alter, nor tamper such certificate data. If forged, altered, or tampered, it is easily detected by the extraction program. Now, the next application we have is Access Control System for digital content distribution. In this area, embedded data is hidden but is explained to publicize the content. Today, digital contents are getting more and more commonly distributed over internet than before. For example, music companies release new albums on their webpage in a free or charged manner. However, in this case, all the contents are equally distributed to the people who can make access to the page. So, an ordinary web distribution scheme is not suited for a case by case and selective distribution. Of course, it is always possible to attach digital contents to email messages and send them to the customers, but it will take a lot of cost in time and labor. If you have some valuable content which you think it is distributable if someone really needs it, and if it is possible to upload that content on the internet in some covert manner, and if you can issue a special access key to extract the content selectively, you will be very happy about it. A steganographic scheme can help realize this type of system. The last application here is media database systems. In this application area of steganography, secrecy is not important, but unifying two types of data into one is the most important. Media data have some association with other information. Steganography can solve this problem because a steganography program unifies two types of data into one by way of embedded operation. So, metadata can easily be transferred from one system to another without hitch. In conclusion, steganography can be defined as an art and science of writing hidden messages. It is technique of hiding secret data within ordinary, non-secret file or message in order to avoid detection. The secret data is then extracted at its destination. It is a form of security through obscurity. The goal of steganography is to hide messages in such a way that no one, apart from the intended recipient, even knows that a message has been sent. Also, steganography is not same as cryptography. It is distinct from cryptography. Cryptography is a secret manner of writing, whereas steganography is where the meaning of the messages is changed. That is the art of secret writing. But using both steganography and cryptography together can help us to improve security of protected information and prevent detection of the secret communication. So here are the references. Thank you. Please like and share my video.